Hi! Today we're going to take a little walk through the periodic table. With over 100 different atoms, or elements, found on Earth, there needs to be a way to organize them in an ordered and easy to comprehend and analyze manner. And the periodic table does exactly that. It organizes all the elements into columns and rows that well reflect the distinct properties of each of them. The history of this magnificent table goes almost 200 years back to the father of the periodic table, Dmitri Mendeleev. His first ever attempt to organize the elements was based on their atomic masses. While analyzing this table, however, Mendeleev observed that the behavior and reactivity of the elements had a trend to it, and that the same pattern of trends repeated itself after every 7 elements. From there, he reorganized another table that presents itself in periods and groups. There were actually only 7 elements in a period at first, rather than what we now know as 8, because the elements were studied based on their reactivity back in the 1860s. And so, the non-reactive 8th group noble gases were not even discovered yet. Notice that there were a lot of holes in that version of the periodic table, and Mendeleev recognized that too, and made a series of predictions that matched almost perfectly with the modern periodic table we have today, which is still subtly, but technically growing. One way to analyze the periodic table is by looking at the different energy levels of each element's valence electrons, and dividing them accordingly into the 4 different valence orbital shells, which are the s orbital, the p orbital, the d orbital, and the f orbital. Another way to analyze the elements is through their properties. The group 1A metals are called the alkali metals. They're silvery and soft, and they have low melting points and are very reactive. The group 2A metals are called the alkaline earth metals. They have high boiling and melting points. They're softer and stronger than most metals except for the alkali metals. They have low densities, and they react very easily with the group 7A halogens. And they're very active in general, though not as much as group 1A. The d orbital block is composed of what are called the transition metals. They're hard, they have high densities and high boiling and melting points. They tend to have various oxidation states. They're very conductive and tend to form colored ions and compounds. The f orbital block is composed of the lanthanides and actinides series. Lanthanides appear silver white, have high boiling and melting points, are very reactive, and are strong reducing agents. Actinides are all very radioactive due to their overly large nuclei that are very unstable and dense and tend to undergo spontaneous fission. There's a big block composed of a mix of metals, metalloids, gases, and nonmetals. The metals are all normally hard except for mercury, being a liquid at room temperature. Metalloids have properties of both metals and nonmetals. Nonmetals are brittle solids and gain electrons easily. Group 7A are called the halogens. They have very high electronegativities and are highly reactive with the alkali and alkaline earth metals. They also have very low ionization energies in their respective periods. Last but not least, group 8A is famously known as the noble gases. They conduct electricity and vibrant fluorescence, and are odorless and colorless in their elemental forms. They're also the most stable and inert elements in the periodic table because of their full valence shells. This is reflected in their large ionization energies. Thanks for watching!